Okay, hello. Welcome to geometry, our very first section of notes here. You're watching this on YouTube probably, maybe over on my computer. But this is geometry section 1.1, meaning chapter 1, section 1. So our very first section of notes. The objectives, meaning what we're going to cover here, say we're going to identify, name, and draw points, lines, segments, rays, and planes. And the second one is we're going to apply basic facts about points, lines, and planes. So the next slide. Here's some vocabulary that we're going to talk about that you're going to be held responsible for. Most of it you already know. You've had some of this in probably some junior high math classes. Undefined term, a line, what collinear means, a segment, or also called a line segment, a ray, postulate, a point, a plane, coplanar, an endpoint, and opposite rays. That is some of the vocabulary that you're going to find in this lesson and again be held responsible for. Let's move on to the next slide. The most basic figures in geometry are undefined terms, which cannot be defined by using other figures. The undefined terms, point, line, and plane, are the building blocks of geometry. Point, line, and plane. I'm going to circle those, and you should probably do the same thing. Point, line, and plane. Those are the three building blocks of geometry. We can't really define those using other terms, like a square. We can define a square by maybe first explaining rectangle. We can't do such a thing with a point or a line or a plane. Next slide. Here's a nice little chart that defines point, line, and plane better. Let me start here with a point. I'll circle it. A point names a location that has no size. It is represented by a dot. That's the term, that's the vocabulary. The name here in this chart is always a capital letter. It doesn't have to be P. It can be any of the 26 letters of the alphabet. They're just using P for point. Pretty clever there. The next column is the diagram, and that's what it looks like. It's literally a point, a dot, with a capital letter. Again, it doesn't have to be the letter P. It could be A, B, C, or anything. The next one here is a line. A line is a straight path that has no thickness and extends forever, meaning it goes on until infinity. The next column, a lowercase letter or 2 points on the line. A lowercase letter like this L right here. Notice that's kind of a italics or scripted L. We can also call it this XY, 2 letters, 2 capital letters, and notice the arrow that's above it. We can also reverse those 2 letters and say YX, again with the arrows or the line above it. And this right here is a diagram of a line. Notice that point X and point Y are on the line. And notice this little scripted L off to the side also names the line. So we got point, we got line. The third one is a plane. A plane is a flat surface that has no thickness and extends forever. A plane is a flat surface. So think of it like in our classroom, the floor. The floor that we walk on is a plane. Don't confuse this with an airplane. Not the same thing. How do we name it? 2 ways. A script capital letter or 3 points. It requires 3 points sometimes to name a plane. We could use this script letter R, or 3 letters, A, B, C. Now it says 3 letters, but sometimes in this class we're actually going to use 4 letters. So really, let me clarify, it takes at least 3 letters to name a plane. At least 3. It could be 4 or even more. Notice in this last box, I'll circle all that, that's what a plane kind of looks like, or how they draw a plane. Notice the points A, B, and C are in there, and notice the script R that's in there as well. Next slide. It reads, points that lie on the same line are collinear. That word collinear means points that lie on the same line. K, L, and M are collinear. K, L, N are non-collinear. So if you look, here's K, here's L, there's M. They are collinear. They're all on the same line. But if you throw in this point out here, N, that's non-collinear. Keep reading. Points that lie on the same plane are coplanar. Otherwise, they are non-coplanar. Next slide. Example 1. Naming points, lines, and planes. We have this, what looks like a pyramid, a bunch of lines running through it. Name 4 points. Right here. A. Name 4 points that are coplanar. 4 points that lie in the same plane. Here's an example. A, B, C, and D. I'll circle those for you. Here's A, there's B, C, and there's D. Now the point would be this vertex. I'll color them in or darken them in my red. And D would be right in there. Those points lie in that, which looks like a square or a rectangle. Part B, name 3 lines. Here's a sample answer, possible answer. AE, which would be, AE would be this line right here. I don't know if you can see that. Hopefully you can on the video. BE, so B to E would be this line right here. Or CE, which would be that one right there. Now it only says to name 3, and so we'll stop right there. There are other possibilities. Moving on to the next slide, here's some more definitions. Another big chart here. A segment, or a line segment, is the part of a line consisting of 2 points and all the points between them. We name them like this. Now when I say I name them, I always like to use, if we put a picture of a line segment in our yearbook, off to the side would be the name. This is what it would say right here, what I have circled, off to the side in the yearbook. And then this, I'll circle this, that would be what the picture in the yearbook would be. AB. Now, you can measure the length of a line segment. You can put a ruler down and measure it. You cannot measure the length of a line because you cannot measure infinity. The next one, an end point is a point at one end of a segment or the starting point of a ray. We name these by a capital letter like C or D. And right there, there's an endpoint C, there's another endpoint D. That's what an endpoint is. Third one, a ray. A ray is a part of a line that starts at an endpoint and extends forever in one direction. One direction. So it's kind of like half of a line. The middle box says its endpoint and any other point on the ray, meaning like this. Noting that's how you name it. You name its endpoint and any other point on the ray. Notice the arrow right here above RS only has one arrow on it. It's just going to the right. RS. You could not, here's a diagram, I'll circle. This is RS, this is RS. You could not name this SR and put your arrow that direction, because S is not the endpoint. R is the endpoint. So don't do it this way. The fourth one, opposite rays. Opposite rays are two rays that have a common endpoint and form a line. In other words, it's like the left side of the line and the right side of the line. You would name these by the common endpoint and any other point on each ray. So it could be like this right here is how we would name them. Now notice that's endpoint E going to F. So endpoint E going out this way towards F. The other one is endpoint E going towards G. So starting here and going towards G would be the other ray. Those are opposite rays. Example 2, drawing segments and rays. Draw and label each of the following. So part A segment with endpoints M and N. Something like this. A line segment, with endpoints M and N. For letter B, opposite rays with a common endpoint T. So T would have to be in the middle. It would look like that. Opposite rays with a common endpoint T. Now, a lot of times you're going to have other letters out here, like this could be point A, and out here would be point B. We don't have to do that because the problem doesn't tell us to. Next slide. Check it out. Example 2. Draw and label a ray with endpoint M, meaning point M, that contains N. So a ray, endpoint N, M contains M, would have to be something like this, maybe. Don't forget your N on there. Endpoint M contains N. Notice there's just one arrow on a ray. Let's keep moving. A postulate. Here's another definition. A postulate or axiom, same thing, postulate, axiom. You're going to hear that word a lot through this school year. Is a statement that is accepted as true without proof. Postulates about points, lines, and planes help describe geometric properties. A postulate is nothing more than a rule that we don't try to prove. We can't prove it. It's just a rule. We have to accept it to be true. It's a rule of geometry. We're going to have a lot of rules in geometry, a lot of postulates, axioms. Postulates. These are numbered, and they'll be numbered through our book. Notice it's 111, 112, and 113. Here's the first postulate, 111. Through any 2 points, there is exactly one line. In other words, if you draw 2 points and put a ruler down through them, could you draw a second or even a third line through those 2 same points? The answer is no. We just accept that to be true. We don't try to prove that. It's just like it's intuitively obvious. Through any 2 points, there is exactly one line. So here's my 2 points. It's one right there and one right there. I can only draw one and only one line through those 2 points. The second postulate, 112. Through any 3 non-collinear points, there is exactly one plane containing them. So here's point 1, here's point 2, and there's point 3. I can only put one plane through all 3 of them. Think of a tripod. A tripod has 3 legs. There's 3 points touching the floor. The third one, 113. If 2 points lie in a plane, then the line containing those points lie in the plane. So that means is if this point and that point are in this plane, then the line that goes through them is also in that plane. And remember, a plane is just a flat surface. It's not an airplane. Next slide. Example 3, identifying points and lines in a plane. Name a line that passes through 2 points. Name a line that passes through 2 points. It'll be something like this, X, Y. Notice the arrows that's above it. That's how you name it. If that was in the yearbook, off to the side would be the name. And it would be that right there, X, Y with the name above it. Another way of saying it is YX with the line above it. So that would be acceptable as well. Check it out. Example 3. Name a plane that contains 3 non-collinear points. Name a plane. Remember how many points it takes to name a plane. It takes at least 3. So this plane could be plane GHF, just 3 points. But it could also be this kind of subscript R. Not very good at writing them. We can do what's just 1 point there. The scripted R would be acceptable. Either way is fine. More postulates, more rules of geometry. These are rules that we don't prove. We just accept them to be true. Intersection of lines and planes. 114. If 2 lines intersect, then they intersect in exactly 1 point. If you draw 2 straight lines that intersect at more than 1 point, that doesn't make any sense. That's just a fact of geometry. The next one, 115, if 2 planes intersect, and they intersect in exactly 1 line. 2 planes, look around the room that you're in right now, and look at 2 walls that come together, like maybe the wall in front of you and the wall off to your right. Don't they intersect at a corner? That corner would represent in geometry a line. If 2 walls intersect, they wouldn't intersect at 2 different corners if they're truly planes, meaning true flat surfaces. Next slide. Use a dashed line to show the hidden parts of any figure that you are drawing. A dashed line will indicate the part of the figure that is not seen. What does that mean? I'll come back to that in a second. Example 4, representing intersections. Part A, sketch 2 lines intersecting in exactly 1 point. 2 lines intersecting in exactly 1 point would be something like that. Just make an X. For part B, sketch a figure that shows a line that lies in a plane. You would draw something like this. Now let's get to that dashed figure part, dashed line part on our very last slide. Check it out, example 4. Sketch a figure that shows 2 lines intersect in 1 point in a plane, but only one of the lines lies in the plane. It'll look like this. And this dashed line part, meaning that that line is poking through the plane. So this line that goes left and right is in the plane. It lies in the plane. But this line, change colors, I'll go to green. This line here is kind of poking through the plane. Like think of your pencil and poke a hole on a piece of paper. And that those dotted lines represent the part that's coming out of the plane at the bottom of the paper. That's what the dashed line is for. And you will see that throughout this school year. Hey, thanks for watching. We are finished with this first video.